Hey there, guess what? Working with proportions again. Woohoo! We are talking about similar figures and how corresponding sides on similar figures are proportional. That's the big focus. Now, there's going to be a lot of symbols and vocab that we have to throw in there so it all makes sense and we can communicate efficiently about this idea. All right. Um, so we're gonna be finding missing measures in similar figures, and we'll also talk about scale factors and how that relates. All right, anytime things are proportional, you can have a factor, a scale factor. Sometimes we call it the constant of proportionality. In different situations, it's called different things. Today, it's the scale factor. All right. Now, before we get really moving, we have to nail down some of these symbols. Geometry is full of symbols, and if you don't know what they mean, you're going to be lost because it's like another language. We'll start over here with these two symbols. All right, we got the equal sign with the little tilde, the little squiggle on top. We use that, we say is congruent to. All right, that symbol is red, is congruent to. So if we look over here for an example, we have this symbol, which looks like less than, but it's not, because that bottom part is actually purposefully horizontal. All right, so this symbol means angle A is congruent to angle X. That means they are the same size. So if we look at these two shapes, we can see that angle A and angle X are the same exact size angle. All right. The other symbol or notation kind of that shows that is that this has one arc inside and this has one arc inside. All right. So that will also show you what the corresponding sides are. I mean, angles are. Okay. You can see that B has two arcs and Y has two arcs. So those are corresponding as well. All right. And that's written right here in this type of notation. Okay, now the other symbol is this squiggle, and that is red, is similar to. Is similar to. So we can see that in use right here. Triangle ABC, that's this guy, is similar to triangle XYZ, and that's this guy over here. All right, so these are the symbols that we will be using. But we have to talk about what does it mean to be similar to. So we know that this is how to write it, but what does it mean to be similar to? All right, and kind of the simplest way to say is that it's two shapes that are different sizes but the same exact shape. Now let's define that a little bit. What makes them the same shape, even though they're different sizes? Well, what makes them the same shape is that their corresponding angles are congruent. Okay, the corresponding angles are exactly the same angles. They're the same. They would measure the same if we used a protractor to measure them. The second part is that corresponding sides are proportional. All right, corresponding sides are proportional. What's that mean? I can kind of show it a little bit here. All right, first we'll check the angles, okay? So the corresponding angles, right? If I take that top left angle and I put them together, you can see that they are the same exact angle. All right, if I take the bottom left and I put it right in that shape, in that corner there, you can see that those are congruent. And if I take that the third angle and put it, match it up, you can see that so we say the corresponding angles are congruent. All right. And now the second part is a little bit harder to show. Hopefully I can do that. But this line, this little extra line here that I placed, it's actually the same length as this. So what I'm showing is that if I double that length, all right, I double that length. So essentially put another of itself right next to it. All right, if I double that length, then sorry, I need one little help here. Oops. There we go. That should, oh no, it keeps asking to grab just, all right, there we go. All right, sorry about that delay. Okay, now I'm going to put those corresponding parts together, and I'm going to shrink this down a little bit so that shrink this down a little bit so that we have it right. See the edge of that, right? The doubled. Okay, so now my larger triangle has double the side length of the smaller. Okay, just that, I only doubled that side length. But notice how the other relationships are the same. So these corresponding sides, right? This one here of the smaller and this longer one here, okay, that's also doubled. You can see that that's halfway. If I measured this and this, okay, they'd be the same, so doubled. Now the last pair of corresponding sides would be that bottom part, and if I slide that up there, okay, oops, a little bit over. No, 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 no. All right, if I put that up here like this, you can see that from here to here, and the whole bottom is also doubled. All right, so there's a scale factor, and therefore it must be proportional. If I did the ratio of each of these pairs of sides, all right, they would be 1 to 2, smaller to bigger. All right, so when we have similar figures, there's two important pieces. The corresponding angles are congruent and the corresponding sides are proportional, and we can set up proportions to find missing parts if we need to. Okay, next step is to talk about corresponding parts and how to show that, how to write this abbreviated way of showing. So this one's a little bit easier because yes, this shape was expanded, it grew and became this shape, but it wasn't turned, rotated, or flipped at all. All right, it was just kind of slid over perfectly here. So it's really easy to find the corresponding parts. A corresponds with E, B corresponds with F, C corresponds with G, okay? And you can see how to write that here, all right? Then corresponding sides, AB, so that's AB, corresponds with EF, EF, okay? You can see how those side lengths are corresponding. They're the matching side lengths. Okay, they're not necessarily the same. If we were to measure them, they're not the same length, but they correspond, and that's what these are saying. Now, one little key is that if I'm talking about AB right here, all right, and I can't say FE, I have to say EF. All right, when you write these statements here like this, the order of A, B, and E, F actually matters. The first letter you write has to correspond with the first letter in the second part, in the name of this line, okay? Because A and E correspond, all right, A and E have to be written in the same position in the name, okay? B and F are corresponding buddies, all right? So they have to be written in the same position, and in this case, second. So you couldn't say AB corresponds with FE, all right? You have to say, if I put AB, I have to put EF. Okay, if I put BA, then I would have to put FE, right? If I reverse these two, I have to reverse these two because the corresponding letters have to be in the same position in the name. All right, moving on. Now we get into the actual math of it. Well, I mean the actual work of it, setting up the proportions and solving the proportions. Okay, since corresponding sides are proportional, you can use a proportion or the scale factor to determine the measures of the sides of similar figures when some measures are unknown. All right, and here we have it. This is an easier one because they're in the same orientation. There was no rotation. There's no flipping. You can see that the top angles correspond, right? B corresponds with E. All right. Down here on the next problem, that's not the case. This is flipped. Okay, it's flipped. We call it a horizontal flip. All right. R now is flipped over to it was on the left side of this object, but now it's on the right side of this object. All right, so this one gets a little bit tricky. You're going to have to take your time more with that, but we'll start with the easy one up here. All right, the figures are similar. So when they make that statement, you know two things. You know the measurement of all the corresponding angles are equal, and you know that all the corresponding sides are proportional. So what's that mean? How do we show that? Well, we know that six, oops, I don't want to do that one first, sorry. We know that we have the numbers for both of these and they're corresponding. So that's kind of our foundational ratio there. And all the other corresponding sides, okay, have to be in that same ratio. All right, so you see that they wrote here, all right, that's our pair with the missing part, and this is the pair that has both pieces of the ratio. Okay, so 4 compared to 12 that ratio has to be the same as 6 compared to what? Or 6 with what? Okay, and we can find that in proportion. All right, these fractions have to be the same. All right, so we can cross multiply and find out that it's 18. You could also see the relationship here. Well, this is 4 goes into 12 3 times, so 6 goes into what? 3 times? 18. All right, so you just have to make equal fractions there, or you can just cross multiply and not even have to think about it that much. All right, but what was the point? You had to find a pair of corresponding sides where you know both numbers. All right, that's going to be what's going to help you find the missing one for a pair of corresponding sides, right? That's going to help you. All right, so you put those two ratios and solve. Next, we have this one. It's going to be a little bit trickier, but we first find, okay, this corresponds with this. So that is our ratio that has both parts of it. And we're going to use that here as a kind of our target. And then we've realized that, that corresponds with that, but we're missing one. So we write that ratio here, and then we cross multiply and solve to figure out that missing side length. Okay, one important thing is that when you put these ratios in, you have to make sure that the top number is both coming from the same shape. Okay, see? So you're going from, in this case, you're going from this shape. Your ratio is the length on this shape to the length on this shape. See, the ratio is the length on the larger shape to the length on the smaller shape. And this one also says the length of the larger to the length of the smaller. Okay, so you just have to have them agree. They have to be the same, coming from the same shape there. All right, try these ones. Hard to teach this on a video, so do your best. Set up the proportions and solve for 1a here and 1b here. All right. 1a will probably be a little bit more simple because there's no flipping or turning. Just be careful here. This was kind of rotated a little bit to make sure you have the right corresponding pieces put together. There's the answers, and I hope you did all right there. All right, so I'm going to show you how to do this one, and what I'll do is, okay, corresponding side. So it looks like this guy corresponds with this guy. So I'm going to make my ratio and the smaller one to the larger one. And then, oops, I have this and this. Those are corresponding pieces. So smaller is B to 24. All right. So then when I Cross multiply, I get 30b equals 20. Divide by 30, divide by 30, and b equals 4. Okay, and that's 4 centimeters. Now, whoa. Now the next one, a little bit trickier, but I'm looking at, let's see. Oh, lots of information here. Well, I have this information. I have the 14 centimeters here, which goes from the double arc to the triple arc. If I find the double arc and the triple arc, that would be this line segment here. So that means that this 14 and this, that's my completed pair. So I can use that. I can use that information. I'll go 7 to 14, corresponding side lengths. All right, and then I'm looking for A. So I have to go with its corresponding side. So that'd be the 1 to the 2 arc, 1 to 2 arc. So that's this one here. All right. And I'm going smaller to larger in my ratio. So I'm going to go put the 4 on top and the A on the bottom. All right, now I can solve proportions in other ways. They're just equal fractions. So if I see that this is equal to 1/2, right, the 7/14 is equal to 1/2, then what would make this equal to 1/2? And that would mean A would have to equal 8. Okay, or I can do the cross multiplication thing and solve it that way as well. Okay, but I know that A equals 8. Woohoo! So I hope that was helpful. That it's going to take some time to really get used to this, but hopefully with some practice, you guys will be experts. Good luck.